Hello, everyone, and welcome back to AI with Cup of Java, Week 6. My name is Anika Ryan, and I will be taking you through today. Um, let's get started with logistic regression. So what is logistic regression? Despite its name, logistic regression is a classification technique, and that means that it's used when the outcome is a binary value, yes or no, true or false. And I would highly encourage you to go back and look at what exactly um, regression is if you're not quite sure. And these are in most of our previous videos in the AI section. So the caveat with logistic regression is that it gives you the probabilistic value that lies between 0 and 1. So if your label is 0, it gives you the probabilistic value that your output is 0, and vice versa. So this function is defined in a way that it should be it should be able to tell us our weights and biases, and we then multiply the inputs with those weights and add it with the bias, and the end result will go into the sigmoid function that gives us a probability to between 0 and 1. And these weights and biases are definitely chosen at random at first, but the gradient descent algorithm will make sure that these parameters are updated to do a good job to do a classification task. And with the help of the sigmoid function, we can successfully predict the output in terms of a probability. So down here, you can see a good graph of logistic regression. You can see our upper bound here, which is y equals 1, our lower bound here, which is y equals 0, and it's kind of S-shaped curve that goes between them. And our goal here, as I already said, is to squish all our data as high as possible or as low as possible. And you can see all these data points on either 0 or 1. So, what is the cost function? This function is defined in the way that it should be able to tell us how much the prediction of our model deviates from the original outcome. So what we need to do is we need to split our cost function into two parts. And one part will explain the function when the actual output is 1, which is this one up here. And the other one will explain the function when the actual output is 0, which is this one down here. So we would like our model's prediction to be as close as 1 as possible when the actual target is 1, or as close to 0 as possible when the actual target is 0. So when y equals 1, we want our cost function to increase the penalty as our model's prediction goes further away from 1 and towards 0. And our model penalty should decrease as its prediction comes nearer to 1. So our objective is to now define a function for this purpose, and that's where the negative log function comes in. When y equals 0, we want our model's prediction to be as close to 0 as possible, and that means we lower our penalty for values closer to 0 and higher our penalty for values further away from 0 and closer to 1. And the appropriate function to demonstrate that is negative log of 1 minus h theta x. So the two parts this cost function are now prepared. So to ensure that the first part activates when y equals 1, and the second part doesn't interfere, and the second part activates when y equals 0, and the first part doesn't interfere, we add the y and the 1 minus y terms to the cost function at the end. And that's where we will get our next cost function over here. So you can see the y minus 1 and the y functions here. And this may look overwhelming, but if you break it down, you'll find that it's actually very simple. And it's just combining our two cost functions that we had before into one single equation. And once you have all your numbers, it should feel less intimidating to look at an equation this long. And most of the time, you'll never have to see this equation because you'll be coding it, and it'll be in a much simpler and high-level way to understand. So now that we have defined a cost function, the aim is to find an optimal weight and bias such that it minimizes the cost function for a data set. This is where gradient descent comes in. So by doing this, the model learns the parameters to reduce its penalty, thus making much more accurate predictions. So we would like to find how the cost changes with respect to the weights and biases slowly to get the optimal parameters. So after finding our gradients, we need to subtract our gradients from the original weights and biases. And we subtract so that we move the value of the gradients in the opposite direction to the slope to make sure the cost is decreasing, because we want to get as close to 0 and 1 as possible, as I explained before. So the cost function is a function that tells us how much our model deviates from the most ideal model. So making sure that our parameters are optimized in a way to reduce cost function will ensure that we get a good classifier, assuming that the points are linearly separable and some other minor factors. We also need to update each parameter simultaneously for each iteration. So we need to loop through all the parameters in the vector. So the update rule is the same one derived by using the sum of the squared errors in linear regression. And as a result, we can use the same gradient descent formula for logistic regression as well. And by iterating over the training samples until convergence, we reach the optimal parameters leading to the minimum cost. So now that we've learned all about logistic regression, what we're going to do is you guys are going to go back to the lab that we had previously, and I'll pull it up on my screen shortly. But you're going to go back to the lab we had previously, and you're just going to tweak it a little bit. So you're going to change your weights, your learning rate, and your gradient vector count, and we're going to figure out, and you're going to see what your ending weights are once you run this model. And this is a data set. I will pause right here so that you guys can take a screenshot. And once you take that screenshot, you can input that data back into your code. And you can play around with it and see what gets you the lowest weights. I mean, sorry, my bad, the lowest error. And so I'm going to pull up the previous code very fast. So yes, as you can see, we just went through the entirety of the code together. So at any time if you wanted to pause and stop the video or go back, I would highly recommend you do that. And yes, thank you guys so much for watching our week 6 of AI with Cup of Java. I hope you enjoyed this lesson on logistic regression and you learned something new. And I hope to see you guys all again next week. Bye.